Okay, today I'm going to be teaching you how to add and subtract polynomials. But before we get to polynomials, we need to talk about a few things, get a couple pieces of vocabulary down. What a monomial is, and also what a polynomial is, all right? The first thing we're going to talk about is monomials. All right. Instead of giving you a big, long definition, I'm going to give you examples of monomials first. Monomials are multiplication and division problems that have no addition or no subtraction. So, for example, 10 is a monomial, 3x is a monomial, 1/2 ab squared is a monomial, negative 1.8 m to the fifth is a monomial. Now, I'll get to degrees in a minute, but let's just focus on that first. It can't have adding or subtracting, and it also can't have some other things. So, it can't have a sum or a difference, no adding or subtracting. You cannot divide by, the denominator cannot be a variable, so you can't divide by a variable. The power can't be a variable, and you also can't have negative powers, which is basically saying these two are saying the same thing, right? Because if you put that on the bottom, it's 1 over x, so these are saying the same thing here, right? Okay, no addition or subtraction, no dividing by variables, no powers of variables, and no negative powers. Okay? That is what a monomial is and what it's not. Now, if you took a group of monomials, for example, if I took the 10 and I took the 3x and I added them together, it is not a monomial anymore. It's called a polynomial. Because what you do is you look at each chunk separately and you say, is that a monomial? Is 10 a monomial? Yes. And then you look at the 3x by itself. Is 3x a monomial? Yes. So together they're a binomial, which means two monomials put together. Got it? Pretty simple. All right. If it is a monomial, then what you need to do is look at the power of the variables, okay? And that will tell you the degree of the equation. All right. The degree helps you to, when you get into higher level math, the degree sometimes helps you to know how many times the graph crosses the x-axis, which may be a little bit confusing to you right now. But it'll tell you stuff about the curve sometimes. And remember, we're talking about curves in this chapter for the most part. Right? So what I do is I look at the degree of the equation. Well, if there was a variable here, it would have to be, let's call it x. What power would it have to be to be gone? Well, it had to be to a 0 power. That's why the degree is 0. So when you don't see anything, it's to a 0 power. Okay? This one is to the first power, right? The x is to the first power. I don't care what the power of the variable is. I care what the power of the, I don't care what the power of the number is. I do care what the power of the variable is. What's the power of the variable? 1. All right, next one. If I have lots of variables, this is what I do. If I have a squared, b squared, all right, the degree of this equation is, this is what you do. You look at each one, you say, what degree is that one to? 2. What degree is that one to? 2. You add them together, it's a 4th degree equation. So in this case, this one's a 3rd degree because that's the first power, that's the second power, 1 plus 2 is 3. Sorry about that. You got to hear my doorbell ring and my dog bark, so I am doing these at home. Okay, so that one was a degree 5 because it was a 5th power. That was a degree 3 because it's a 1 first power and a second power, which adds up to 3. First power and 0 power because that's x to the 0, right? Okay, in example 1, we're going to do a couple things in each problem. We're going to determine if it's a polynomial or monomial. You're going to find the degree, and you're going to find the leading coefficient. So I'm going to help you through all 3 of these things. All right. First thing, is this a monomial or not? Well, does it follow the rules of what a monomial is? Remember, does it have any adding or subtracting? No. Is there variable denominators? Is there variables that are exponents? No. So this is a monomial. Okay, so it's a monomial. I'm just going to write mono. Okay, the degree. Remember what I taught you a few minutes ago about degree. What you do is you look at everything, but you look at all the non-numbered variables. So look at just the x. What power is the x to? It's to the 1, so it's a first degree equation. Okay? And then the third thing is, what's the leading coefficient? Okay, the leading coefficient is the first number, which would make it 3. Got it? All right, let's try another one. Is this a letter B? Is this a monomial? No, it's not, because why? It has a variable in the denominator. So I'm done. I don't have to do the degree. I don't have to do anything else. In example C, is this a monomial? Well, yeah, it looks almost exactly like this one, right? So it's a monomial. What degree is it? Remember what you do. You look at all the powers and you add them together. So 2 plus 3 is 5, so it's a fifth degree equation. Okay? Then what do I have to do? I then have to figure out what the leading coefficient is. Well, what number is in front of the A? A 1. Pretty easy, right? All right, next one. Is this a monomial? Well, no, there's a plus sign here. Now this one's special because what you need to do in your mind is you need to break the chunks up. So separate the chunks out. So I have this chunk and I have this chunk, right? And what I need to do is look at those chunks separately and say, are those chunks monomials by themselves? Well, that's a monomial and that's a monomial. So together, if you have two monomials being added or subtracted, then it's a polynomial. So how many monomials do I have? This is a monomial, this is a monomial. I have 2, so it's a binomial. Sorry for the red, but I'm not going to change it now. Binomial. Okay? Now the degree on this one is kind of interesting, so I need to spend a few minutes talking to you about this one. Here's how you do the degree. What you do is you look at each chunk separately. So you look at this chunk. What degree is this chunk to? Well, this chunk is to the 5th, right? Because a 2, oh, not a 5th, a 4th. Because a 2 and a 2 makes 4, right? So this chunk is to a 4th power. And this chunk is to the 3rd power. Now, most people, when they first do these, they think they add them together, so it's 7th. But that's wrong. What you do is you take the higher of the two. So which is bigger, 4 or 3? 4 is bigger, so it's a 4th degree equation. Okay? 4th degree. And then the leading coefficient is the first number, which is the 3. Okay? So the new thing here is to determine the degree. So if I had a whole bunch of monomials added together, so let's do 3a squared plus 2ab plus b squared. What I would do is I would look at each one of these chunks separately, each one of the monomials separately. This is to the second, this is to the second, this is to the second. I don't add them. I take the highest power, which would be 2 in this case. They'd all be 2's, so it'd be a 2nd degree equation. Got it? All right. All right, and let's go down to the next section, example 2. This should be pretty easy for you guys. All right. What you want to do here is you want to simplify this. You can't solve it, but you can simplify it. So what we're going to do is we're going to chunk it like we did earlier in the year. And for this lesson, I actually am going to circle things. So stay with me here. So you look at each chunk. Here's one chunk, and I'm going to make this smaller so everybody can see it better. All right, so we got one chunk here. I've got another chunk here, another chunk, another chunk, another chunk, and another chunk. Got it? All right, then I start combining things that are the same. Remember at the very beginning of the year, probably, I don't know, third or fourth week of school, I talked about this, which was you can add x squareds with x squareds. I can add the x squareds with the x squareds. I can add the x to the thirds with the x to the thirds. I cannot add x to the thirds with x squareds. They have to be exactly the same. Okay? So what can I combine with this? This, right? X to the thirds can be added with x to the thirds. In algebra, we always want to write them higher powers first, and then they need to be alphabetical. So what do I mean by that? X to the thirds have to be before x squareds, and x squareds have to be before x's, and numbers always come last. So x to the thirds would go first, then the x squareds, then the x's. Now if I have two different letters in the equation, then I'd still do them alphabetical. So x to the thirds would go before x's, x squareds, but x squareds would go before y's because you do them alphabetical by their power, okay? So let's do this one. 2x to the third plus x to the third is 3x to the third, right? Negative 5x squared and a 2x squared. A negative 5x squared plus a 2x squared is a negative 3x squared. And okay, so these, what I would do is cancel, mark them off when I use them. Those are gone. Those are gone. I have an x. Do I have any more x's? No, so it's just one x. So just plus x. Do I have any more? The x is gone. Do I have any more numbers? Just the negative 1, so it's minus 1. And I am done. That's all I have to do. You don't have to do this on your homework tonight, but what's the degree of this equation? I'm curious if you can figure that out. The degree of this equation is third because you look at each chunk separately and you take the highest power, which was 3, right? All right, example, looks like we lost an example here, but let's go to example 4. I really do think there's one missing. Example 4. What I want to do first is get rid of the parentheses. Now, since there's an imaginary 1 out here, there's really nothing to do inside that parentheses. So my first thing is I'm just going to write the number. So this is 4n squared plus 5 minus 2n squared plus 2n minus 4. So just drop the parentheses. Chunk it. Look at each chunk separately. All right. What can I add with the 4n squared? The negative 2n squared. 4n squared plus a negative 2n squared is 2n squared. Those are gone, right? I don't do numbers next. I do n's next, right? Because I always do numbers, letters before numbers. So 2n plus what? Nothing. So just test plus 2n. And then a positive 5 and a negative 4 make a positive 1. Done. That's my answer. Okay. Example 5. First thing I want to do is understand that there's a hippo here. I hope you see that hippo because I'm distributing a negative 1, right? I'm distributing a negative 1 to this, a negative 1 to this, and a negative 1 to this. There's a hippo there. Be careful. Hippo. If you don't know what a hippo is because you're not in my class, it's distributing a negative 1. And if you don't know why we call him a hippo, it's actually a fun story, but I'm not going to get into it right now. But you do need to recognize that this is a dangerous problem because you're distributing a negative 1. So let's do that. I'm not going to mess with the first number. I'm not going to mess with the second number. I'm going to now do negative 1 times negative 3x squared is positive 3x squared. Negative 1 times x is negative x. Negative 1 times 10 is negative 10. Now, by now, you don't have to be circling these anymore. All you want to do is combine them. So I think by now you understand what the chunking looks like. But that's what we're going to be doing now. So negative 3x squared plus 3x squared makes what? Those make 0. They're gone. 5x plus a negative x makes 4x minus 10. Done. That's my answer. And there you have it. Adding and subtracting polynomials and monomials. Not hard at all. In fact, it's just building on stuff that you've been doing in my class for a very long time. Good luck with that. And if I find out later on that I'm missing example 3 somewhere, I'll come back and fix it. All right. Have fun.